In this video, we'll solve this problem and we'll go through an important concept in problem solving, which is prefix sum. There's also a complementary concept, which is suffix sum, but we'll go through prefix sum for now. So let's see that problem first. That person killed many monsters and got many stones. She numbers the stones from 1 to n. The cost of the I stone is Vi, and she wants to know something about these stones, so she will ask us two questions. Either she'll tell us two numbers, and we should tell her the sum between these two numbers, or she will want us to sort them first. It's not the hardest problem, but the problem in this is the concept of exceeding the time limit. So we'll see how to fix it. My approach in problem solving is going through the inputs first, and then seeing how we'll solve the problem. So our first input is n, the number of stones. So n is int input. And then the second line contains n integers, the cost of each stone. So we'll have a list. Each item in the list represents the cost of one of the stones. So we'll write it as v equals v brackets, and then we'll use the comprehensive lists. So it will go like int y for y in input, and then dot split. We'll not write anything as they'll be separated by space. So that line basically says that we'll get this input and then split it with space being the separator, and then convert each item to be an integer, and then store that in a list called v. Our next input is the integer m. So we'll do the same thing. M equals int input. And now it says then follow m lines. So we'll go through a loop for underscore in range m. We use an underscore as we'll not use it later in anything. Now each line will contain three integers at type L and R. I'll call it T, L, and R equals. Now instead of writing T equals int input and then L equals int input and like that, we'll just use it like this is more robust. It's better to do it that way. So I'll just write it. We'll use normal brackets and then write int any letter like x for x in input dot split. Now we have all our inputs. So n is the number of stones, v is a list of cost of every stone, m represents like the number of questions or whatever she wants to know, and then our three integers here, t represents the type. So if t is 1, we'll answer the first question. If t is 2, we'll answer the second question. And then L and R represents our ranges. So let's see how we'll approach it. First, I would like to have if and else statement. T is 1. We'll do something, but we'll pass for now. And else, we'll do something else, and we'll also pass. We could solve this problem two ways. The first way is every time we go through the loop, we sort the list and then print the range. That approach will exceed the time limit. The second way is by using prefix sum. So the first thing I'll do is make another list. I'll call it sorted, and that will have everything sorted. Everything in the v list sorted. That will make it easier for us to solve the second question. So this is our approach. That represents our prefix sum array. It will be the same size as our input. So for the first example, we have the following list as the cost of the stones. So the first stone costs 6, and then the next one costs 4. So the size is 6, okay? Let's see how the prefix sum works. So we'll just have an array, and each element in the array would be the sum of this element and the sum of the preceding other elements. So the first element in our prefix sum array would be 6, which is the first element plus whatever elements precede it, which is nothing. And then for the second element in our prefix sum array would be the current element, which is 4, plus whatever precedes it. So it would be 4 plus 6, which is 10. And then our third element would be 2 plus whatever precedes it. We could do it in two ways. We could do 2 plus 4 plus 6, or we could just add 2 to our previous element in our prefix sum. That would be the way we approach it in our code. So it would be 12. And then our next element is 7. 7 plus 12 is 19. And then plus 2 is 21. And then finally plus 7 is 28. So that would be our prefix sum array. And that's the case that we didn't sort it first. If we sorted it, it will look like something else. Now let's go back to our code. Now we need to prepare our prefix sum array in advance before entering our loop. So we'll initialize prefix sum. It would be a list. Everything would be initialized to 0, and the size is n. And then our next list would be prefix sum sorted. That will be used for question 2. Also, it will be initialized with 0 and the size n. Now, to create our prefix sum list, we will create a loop. We'll go through a loop. So we'll say for I in range n, so the size of our list is n. We'll pass for now. We have to do something first. Now, we already know the first element in our prefix sum array would be the first element in V or sorted V. So our prefix sum of 0 is V of 0. So it will be the first element no matter what we do. And then the first element in our sorted prefix sum is also the first element in our sorted V. Now, for I in range n, we'll start from 1 because we already defined the first elements before entering the loop. So for I in range 1 through n, our prefix sum of I would be our current element, which is V of I, plus whatever precedes it. So as I showed you, it would be the current element plus the element before it in the prefix sum array. So for example here, 12 was the sum of our current element, which is 2, plus whatever preceded it in prefix sum array, which is 10. So 2 plus 10 is 12. So it would be our current element plus prefix sum of I minus 1. We could create another loop, but that's not necessary. So we'll just do it here. Prefix sum sorted now would be our element in the sorted V plus the preceding elements in our prefix sum list, I minus 1. Now we created our prefix sum list. We can go through our problem now. So if t is 1, that means we want to print the sum of the unsorted list. If t is 1, we don't need to sort the list first. So just print the sum from the prefix sum list, not the prefix sum sorted list. We'll print our element, which is prefix sum of R minus the prefix sum of L. But first, before doing that, L and R is the order of the element, like they're not zero indexed. So the first element in our V list is ordered 1, not 0. Regarding the question here, L and R start from 1, not 0. So we have to minus 1 from each to make it proper for indexing. And we'll need to do something else. So let's say, for example, our L is 1 and our R is 6. So basically, she wants to see the cost of everything from the first element to the last element, so the sum of everything. If we made prefix sum of R minus prefix sum of L, that will give us 22. But what we actually need is the 28 only. So this is a special case when our L is 1, we'll just print the last element. And also we went through that already, 6 and 1 will become 0 and 5 to be able to be indexed properly. So we'll handle the case of L being 1 and we'll just print the last element. But instead of saying L is 1, we'll just say if L is 0, because we already minus 1 from that, we'll print the last element, which is prefix sum of whatever R we have, and then else we'll print whatever element in R minus whatever element in L. That also won't work, so let's see why. Let's say our L is 2 and our R is 4. So she wants to know the sum of everything between this element, which is the second element, and the fourth element. In that case, it would be 4 plus 2 plus 7, which is 13. If we printed the fourth element in our list minus the second element, that will give us 9. So what's wrong? What did we do wrong? So the correct approach would be we need to minus not our second element, but our element minus 1. So instead of the second element, it would be our first element, which is 2 minus 1. So why is that? 10 here includes 4 and whatever precedes it. But we actually need that 4 in our solution. So we can just minus it. Let's see another example. Let's say our L is 3 and our R is 6. So we want to print the sum of everything between the third element and the sixth element. That would be 7 plus 2 plus 7 plus 2, which is 18. So our third element here is 12 and our sixth element is 28. So the element for our third element is 10. So we'll just do 28 minus 10, which will give us 18. And that's the correct solution. So here, instead of saying prefix sum of L, it would just say prefix sum of L minus 1. And we'll do the same thing in if they wanted t equals 2. So if L equals 0, we'll just print whatever in prefix sum sorted now of that element. And if something else, we'll just print the element in the R minus the element in L minus 1. And that was our video for today. Your feedback would be highly appreciated. Also, don't forget to check out other problem solving related videos in my channel.